concept. All right, a couple things we're going to do here. We're going to talk about Avogadro's number. We're going to talk about molar mass, and we might get to mass percentage. I'm not sure yet, so we'll just see what that plays out. So just basically take some notes pertaining to each of the points that we go through on the slides. And if y'all have questions, feel free to ask before I move on. All right. So Avogadro's number is the first thing we come to. So when we talk about Avogadro's number, it's based around the mass of carbon. And so carbon's mass is 12.01 grams. And Avogadro's number is 6.02 times 10 to the 23rd. So the value of it, 6.02 times 10 to the 23rd. That means that for every 12.01 grams of carbon you have, there are 6.02 times 10 to the 23rd carbon atoms. Now, to give you an idea how big that number is, so when we look at scientific notation, we understand that 23 is a big number, but really how big is that number? So if I started writing this out, I would have a number that big, and this puts it in perspective of how big that number actually is. So there's a lot of atoms packed tightly into a mole of carbon, in this case 12.01 grams of carbon. Now mole is a unit of measurement for the amount of chemical substance. You will be using this unit a whole lot this semester, so this is a unit that you definitely want to make sure that you remember and understand. Now, in reference to Avogadro's number, 1 mole is equal to 6.02 times 10 to the 23rd. That's important because that's a conversion factor. Now, units that you can have here, atoms, molecules, ions. So these are just different units that you can have in relation to Avogadro's number. So it's not the Avogadro number specific for any certain thing. It could be for any of those units. And I could tell you that you have 1 mole of pancakes, just for example, by the way. If I told you to go eat 1 mole of pancakes, how many pancakes would you be eating? 6.02 times 10 to the 23rd pancakes. I don't know about you, but when I eat pancakes, I can eat about 4 or 5 pancakes and I'm done after that. I couldn't imagine eating 6.02 times 10 to the 23rd pancakes. But that's what a mole is. Now, when we think about a sample of carbon that has around 12 grams, think about a number 2 pencil. So if you have a full number 2 pencil, something that hasn't been sharpened, just a number 2 pencil, that's about 12 grams of carbon. So in that number 2 pencil, you have 6.02 times 10 to the 23rd carbon atoms that are present. That's what 1 mole a sample looks like. So when we talk about Avogadro's number, we're talking about very large numbers because the atoms are tightly packed together. And we can use this relationship to convert between different units. So that's what our goal today is to talk about how to do conversion factors using Avogadro's number, moles, and even mass. Mass would be referenced to grams. Now we're not to that point yet for grams, but we can use this conversion factor here. So we've just given you some more comparisons to how big a mole is. So if you talk about a softball, well, it's the size of a softball. You have 1 mole of softballs that's going to equal the volume of Earth. It will fill the entire volume of the Earth. If you have a mole of shot put balls, the shot put ball weighs 16 pounds, by the way. If you have a mole of shot put balls, that's going to equal to the mass of the Earth. Quite a bit. All right, so mole is a big number. So that's the main thing I want you to get from that. So we're going to be using the dimensional analysis. We started this the other day. So yes, there's some text on this, but I'm just going to use my own text here. So remember the T-chart. This is your given unit. All right, well, this is the unit that is desired. And then this is your canceling unit. And this is just a basic way of setting this up. All right. So we're going to use this T-chart. That's what we call this, is a T-chart. And when we did start using this the other day, but I'm going to continue using this throughout the rest of the semester. Something you have to get used to. If you're used to it and you have already used it, then it's great. But if you're not used to it, try to understand what we're doing here. So remember, this is multiplication, left to right, top to bottom is division. So again, we take the given value, we use the unit factor. So this is your conversion factor here, and then that gets you to the answer with the correct unit. So that's what that T-chart is going to help you do. So we're going to get to our first example here that says how many sodium atoms are in 0.120 moles of sodium. So they give you two things. They give you the moles of sodium, and then they ask you how many sodium atoms. So that's your question here. All right. So to go through answering this question, what we're going to do is we're going to take the 0.120 moles of sodium, and we are going to multiply by Avogadro's number, which is 6.02 times 10 to the 23rd. Now what you'll see here is the moles cancel out. And so all we got to do now is just multiply the two together. So we have 0.12 times. Now, if you have your calculators ready or present, I would suggest you look at it at least with me, because I'm going to show you a couple ways how to do this. Normally, I'm able to do this in the lecture hall where I can actually, you can watch me do it on the screen, but I don't have that capability here. So I'm going to try to explain it to you the best I can. So you'll type in 0.12 times 6.02. So normally you would type in times 10 to the 23rd. Don't do that here. So what I'm going to do is show you an easier way to type this in. What you do is find the second key. It's on the top left. And then you'll go and find the comma. Behind the comma, you'll see EE. So just press the comma. So what your calculator will look like is
Could you write it out?
That's what I'm doing. I was trying to find my pen. I could set my pen down. What it will look like in your calculator is this. The E comes from hitting second and then pressing the comma button. That's supposed to be a comma. It looks like a J. Now it looks like a G. I'm going to making it worse here. There we go. Now, once you get this to looking like this, you just hit the equal sign or hit enter, and you end up with 7.22 times 10 to the 23rd. So if you do it correctly, you'll end up with that answer there.
I ended up with 7.224 e to the 22nd.
What? You know what's wrong with me right now? I can't read. Yeah, you're right. It's 22nd. I don't know why I saw 23rd, but old age. Any other questions on inputting that in your calculator? If you're one of the old school people and you don't want to use this E and you want to just do it like this here, put parentheses around it. Always put
Can you
parentheses.
could you
What?
repeat how to put it in the calculator again? Because I didn't get the same
You
answer
want the
that you
short
got.
way? You want the long way?
Give me the short way, please.
All right. 0.12 times 6.02. Find the second button and press it, and then find the comma and press it. You'll see E show up on your calculator. When you see that E, then just type in 2, 3 and hit enter.
Okay.
Did you
Thank
get
you.
it?
Yes.
Good, good. And that's the way you're always going to do scientific notation on your calculator. The E really simplifies it. All right, so now on the slide here, let me erase what I've got here. You'll see that I have it written out, and it has the value, the answer along with the units. So the units in this case are atoms. So you want to make sure that you have your units wrote down. Now the second thing here that I want to do is talk to you about roadmaps. So a roadmap is something that you can use to help you get from point A to point B. When you're doing these problems and you get to a problem that has multiple steps, sometimes it's not easy to get from A to B. Sometimes you got to go from A to somewhere else, then back to B. Now, the roadmaps, there are 4 of them that I'm going to give you. The first one is atoms to moles. I ran out of space here. Atoms to moles. So the way you get from atoms to moles is you divide by Avogadro's number. That's the first roadmap. The second roadmap is going from moles into atoms. And to do that, you're going to multiply by Avogadro's number. Now, in this example that we just looked at, we used the second roadmap to do this because we needed to go from moles into atoms. So that's why these roadmaps are important. So that's 2 of the 4 that I'm going to teach you guys. And so get those wrote down. Flashcards, best place to have these. It helps when you get to those longer problems and knowing what to do. Any questions on anything? All right, so let's look at another one. Okay, so I want you guys to try this one. All right, I'm gonna give you guys a minute to do this. So it's 11:16, so 11:17, I'll come back. All right, so make sure you attempt this. So starting now.
Wait, can you go back?
I know. There you go. Does anybody want to tell me their answer?
Do you want it in scientific or standard notation?
Let's do scientific.
2.08 times 10 to the negative 3 moles.
You're very close. Very, very close. That you are right. Thanks, Sydney.
Oh, shoot. Awesome.
All right. How many of you did okay with that one? You could have got 0.00208. That would also be acceptable. So how many of you got that answer?
That's what I got, and then I put it in scientific notation just in case.
Yep, yeah. And either way is fine. So either way is fine. All right, so that's where we take the first one where you have atoms converting into moles, and then you divide it by the Avogadro's number. So perfect.
I have a question.
Okay, go ahead.
I'm sorry. For the mole of the potassium, it gave you 1.25 times the 10 to the 21st power. What did you do with the 10 to the 21st power?
So in your calculator, what you want to do is you'll type in 1.25 e to the 21st divided by 6.02 e to the 23. So remember, the way you get the e is second comma.
Yeah.
Is that what you're asking?
Yes.
Okay. Does that help you get where you need to be as far as the answer?
Yes. Thank you.
You're welcome. No problem. All right. Are there any other questions on this problem?
Significant figures, is that why we have to put it in scientific notation?
Well, so just to clarify on that, so this number here is 3 sig figs. So when you look at this number here, that is 3 sig figs, so you do not have to convert to scientific notation. The only reason why I did that is because that's just the way I do things. But you're not obligated to put it in scientific notation unless it's necessary. It's not necessary here. So either one of those answers are fine. All right, so let's look at molar mass because that's something I definitely want to make sure we get to today. So molar mass, you all need your periodic table. So if you have your periodic tables, go ahead and get them out. If you don't, find one.
Professor, quick question. For the test, will we have enough time to do the calculations by hand, or would you advise using the calculator for the calculations for when we take the test?
I would definitely use the calculator. I don't think I would ever use my hand unless I just didn't have a calculator. So, okay. Yeah. All right. So periodic table time. All right. So I'm pop quiz you. Y'all are not gonna like me. Actually, this is easy. What's PB? Don't look at it. What's PB?
Lead.
All right. Lead. What is the symbol for chromium?
CR.
Right. What is the symbol for argon?
AR.
Yeah. What is calcium's symbol?
K.
K?
A. TA.
No, calcium.
CA.
Yeah. What do you think I said? That don't matter. All right. What's gold?
AU.
What is right? It's AU. What is AG?
Silver.
All right. Good. Okay. So now we talked about mass number the other day, correct? So if we look at silver, what is mass number for silver?
$107.87.
Yeah, exactly right, you two. 107.87. Okay, so when I say molar mass, you're basically going to look up the number that I just pointed you towards, okay? So for iron, for example, so iron is 55.85 for its mass number, okay? So that's its mass number. Now, its molar mass is also 55.85, but the difference is instead of using AMU like we were using, we're using grams per mole because it's molar mass. Molar, moles, mass, grams. Everybody understand that? You see what's highlighted there? This right here, write that down because that's important. That is a conversion factor, okay? Our molar mass will be used as a conversion factor. So first thing we need to do is figure out how do we determine molar mass. Then we're going to use those molar masses that we determine to calculate either grams or moles in a problem. So let's look at oxygen gas. All right, so I pull this one up because, well, there's a problem in the worksheets where people are missing. Oxygen gas is a diatomic molecule with a formula of O2. And so oxygen gas has two oxygens. Now, the molar mass of oxygen gas by its just one oxygen is 16.00. Now, since there's two oxygens, what you should do is you'll do 16 times 2, which gives me 32 grams per mole. Now, one thing I want you to do and remember here is always carry to the second decimal place. Do not round, carry to the second decimal place. That way you keep all your numbers straight. All right, there's no questions about it. So that's how we figure out the molar mass of a compound. Now, if we are just looking at an element, it's easy. You just look at the periodic table. But when we look at compounds, we have to pay attention to what compound we're looking at. So let's talk about NaCl. All right, there's one Na. Na is 22.99. Chlorine, there's one chlorine, and chlorine is 35.45. So all we need to do in our calculators is just add those two together. So we have 22.99 plus 35.45, which gives me 58.44 grams per mole. So that's not a bad one. That's an easy one. Are there any questions on that? Okay, have y'all got this wrote down?
Yeah, give me just a moment.
Okay, that's what I'm asking.
Okay.
All right. So again, molar mass of substance is the sum of the masses of each element. Now, in this particular example, what we have here is one magnesium. Magnesium is, let's see here, 24.31. There's only one mole of these, so that's all we gotta do. Now we look at the nitrogen. Okay, what do you do with parentheses typically? You distribute. So in this particular example, you have two nitrogens. The molar mass of a nitrogen is 14.01. So that's going to give me 28.02. And we're going to do the same thing for the oxygen. Now in this case, it's 3 times 2. So that's 6 oxygens times 16. Which gives me 96. So now we just need to add these three together. So we have 24.31 plus 28.02 plus 96. And that's going to give me 148.6 0.33 grams per mole. Any questions on that? Okay, let's move on here. So now we're going to use molar mass of a compound to convert between grams and moles of a substance. So remember, the Avogadro's number is 6.02 times 10 to the 23rd atoms per mole, and then now you have molar mass. So your mole is the central unit here. So we have our conversion factors, the roadmaps up top. So we had atoms to moles, moles to atoms. Now we're gonna write two more, 3 and 4. So now we're gonna have grams to moles, and then moles into grams. Now to convert grams into moles, I'm gonna write this bigger so we can see it here. So what I'm gonna do is divide by the molar mass. If I want to convert moles into grams, I'm going to multiply by the molar mass. And MW is just molar mass, so you all know that. Okay, so let's say we have 0.5 moles of NaCl, and I want to figure out how many grams of NaCl I have. So what I'm going to do here is look at my roadmap and figure out which one of the I'm going to use. So I noticed that roadmap 4 is going to be the best match because it's going to go from moles to grams. So in that roadmap 4, I need to figure out the molar mass of sodium chloride. So I'm going to take 0.5 moles and I'm going to multiply by the molar mass. In this case, that's what, 25. What was the molar mass of NaCl again? 58.44. So I'm going to multiply by 58.44 grams per mole. Now the moles cancel out here because they're dividing into each other. And what you end up with is 29.22 grams NaCl. So that's how you use that as a conversion factor, all right? And the roadmaps really do make a difference. Just make sure that you understand that it really depends on what you start and where you stop as far as the units goes. Sometimes you'll have to go, let's say you want to convert grams into atoms. Well, there is not a roadmap where you can go straight from grams into atoms, all right? But you can convert grams into moles. That's using the third step, and then you look at step 2, the roadmap 2, then you can convert moles into atoms. So when you get to a problem like this, there are problems that have multiple steps. In this case, you have the first step, which is grams to moles, and then you have the second step is moles to atoms. So that's where these roadmaps come into play. They're going to help you with going from the starting point to the finish point. So we get to a problem like this. What I want you guys to do is I'm going to give you guys a couple minutes. I want you to work on this problem. I want you to figure out how many grams of titanium are in 1.33 moles of titanium. Okay, so Again, I'll give you guys 2 minutes to do that. It is 10:33, so 10:35 I'll come back. All right, get started on it. All right, let's see what we got. So in this problem, what you need to do is going to convert from moles into grams. So the molar mass of titanium was 47.88. So based off the roadmap, you're going to multiply by the molar mass. So you should end up with 63.7 grams of titanium. How many of you got that answer?
I got that.
Okay, good. Anybody else?
I did. I just messed up on the significant figures.
Okay. Yep. Who else was talking as well?
I got that too.
All right. Good. So let's do another one. I know y'all excited. You have this new knowledge, so you want to practice it, right? Here's your next one. So 2 more minutes. So 2 minutes, go for it. So 10:38, I'll come back. So we have about another minute left here, and we'll come back together. All right, does anybody have an answer for this? How many of you were able to finish this? If not, I'm gonna give you guys another minute. Do y'all want another minute or two to work on this?
I'll be done in like 10 seconds.
Okay, yeah, okay. I'm gonna give you another 2 minutes. So 10:40, I'll come back. All right, so it's almost 10:40 here. Now, have more people been able to finish this now?
Yeah.
All right, good. Okay, so I'm gonna go start working on it here. So this problem is dealing with atoms. So you have atoms, and we want to solve for mass, and mass is grams. So this is a problem where we have to convert atoms to grams. So this is not a simple just one step type problem. So the first thing we're going to do is we understand that atoms can be converted into moles. So that's what we want to do first. And then the second step will be converting moles into grams. So if you want to convert atoms to moles, you're going to divide by Avogadro's number. And if you're going to convert moles to grams, you're going to multiply by the molar mass. Those are the two steps that you have to do. Now, the way I did it here is I took my atoms, I divided by 6.02 times 10 to the 23rd, then I multiplied it by 207.2, which was the molar mass of lead. And so what I end up with is my final answer is 87.8 grams of lead. Did anybody get that problem correct?
I did.
Yeah, I did.
All right. Does anybody have any questions on how to do that problem?
So for significant figures, like I got 87.77, but I was looking at the 2.55 for the sig figs. Is that what you use?
Yes. And that's 3 sig figs. So when you look at the scientific notation, the sig figs comes from those 3 numbers, nothing else. All right, so one more problem here. Let's do this one a little bit faster. All right, so let's not 2 minutes here. So 10:44. So I'll come back in 2 minutes. Knock it out. 1 minute left. All right, so let's go over this one here. So molecules is not moles. That's the first thing you have to understand. Molecules are atoms. So to do this, what we need to do is understand that we're going to be going from atoms to moles, and then moles into grams. Did any of you think that molecules were moles? All right, good. Nobody said anything. That's great. So go about this. We convert grams into moles. So I wrote the roadmap backwards, but going from grams to moles, divide by the molar mass, and then convert moles into molecules, which is multiplying by Avogadro's number. So you end up with 8.84 times 10 to the 21st molecules of oxygen. So remember that this number here is 3 sig figs. So you want your final answer to be 3 sig figs. Any questions on that? Okay. All right. So there's one more thing that we need to do, but I don't know if we have time to do it completely here today. So what I am going to do is pull it up here. We're going to be getting into percent composition. That's the last thing we look at. So this slide.
Can you go back for 1 second?
What?
Can you go back for 1 second? Okay, thank you.
You're welcome. So this slide gets us started with percent composition. So the law of definite composition states that compounds always contain the same elements in a constant proportion by mass. So sodium chloride always has 1 sodium and 1 chlorine. The way that we figure out the percent mass is, in this case, percent composition. We look at the molar mass. So sodium chloride has a molar mass of 58 grams per mole. Now, sodium by itself is 23 grams per mole, and chlorine is 35 grams per mole. The way this works is you take your 23, divide by 58 times 100, and that's where you get the 39% from. You do the same for chlorine, where you take 35 divided by 58 times 100, and that will give you the 61% that you see there. And you can always check yourself by adding 39 plus 61, and that'll total 100%. You want it to be total 100% as it is mathematically, because it's always out of 100%. So that's how you do percent composition. Percent composition is based off the law of definite composition. Are there any questions on sodium chloride here? Now, I do have other examples that run through here. There's your glass of water if you're thirsty. All right, so chemical formula. I'm going to move on through this slide here. And moving on through here, it just gives basic explanation. We understand that by now. So, yeah, moving on from there. And here we are, percent composition. So, this is the example that deals with water. All water contains this amount of hydrogen, and this amount of oxygen, so 11% hydrogen and 89% oxygen. How do you figure that out? So the way you do this is you take the mass of hydrogen, which is 1.01, multiply by 2 because there's 2, add that to 16. That gives you the molar mass of water, which is 18. Now, to figure out the percent mass, you take the 2.02 grams of hydrogen divided by 18 times 100. That's how you get the 11%. And you do the same thing for oxygen. So you have 11% hydrogen and 89% oxygen. I'm just rounding up and down here. So, but if you were add these two together, hold on, go back here. If you add these two together, that will add up to 100%. So that's dealing with a simple compound. Now, if we deal with a bigger compound like TNT, so now we have a little bit more complex molecule to work with. So the first thing you got to do is figure out the molar mass of it. So the molar mass is 227.15 grams per mole. Now, do understand that you have this PowerPoint on Moodle. You can go back through this PowerPoint and you can look at everything again because I'm going through it a little bit quicker. We only have about a minute left here, so that's why I'm moving on. So the way we do this is we figure out percent of carbon. So to figure out percent of carbon, we figure out the total mass of carbon divided by the molar mass times 100, which gives you this. And we do that same concept for all elements. We do it for hydrogen, we do it for nitrogen, and we also do it for oxygen. So again, at the very end, to always check yourself, make sure you add these percentages together to get a total of 100%. If you don't have 100%, you did not do something correct. So you want to go back and check yourselves.